Alright, so this is your integrals in test review. So here's number one. It says to find the antiderivative of this function. So we're going to do the integral of negative 10x to the 8th minus 6x to the 5th plus 8 dx. Alright, so this comes out to, remember, the negative 10 doesn't really change. The x, you're going to add 1 to the exponent and then divide that term by 9 because that's the new exponent. And then minus 6x to the 5th. Well, that 5 you're going to add 1, so it's going to be 6, and then you're going to divide by the 6, plus 8, and of course now that has to be 8x because you can look at this as technically, whoops, x to the 0. So x to the first, and of course dividing by 1 doesn't do anything. Now we can take this one step further by canceling out those two 6's there to give us a final answer of negative 10x to the 9th over 9 minus x to the 6th plus 8x, and don't forget plus c. Alright, so this was your f prime of x, and now this is your original function f of x. And remember, it's just a generic function because of the plus c. They would have to give us a little bit more information to actually figure out what c was. Alright, so there's number one. Number two, it says to integrate or evaluate this function. So the first thing we're going to have to do is take the antiderivative. Alright, so the antiderivative will be negative 3x to the 6th over 6 minus 4x to the 5th over 5 plus 7x evaluated from 2 to 4. Now, right here with this negative 3 over 6, this 3 will cancel to a 1 and this 6 will cancel to a 2. So we can replace this first term with negative x to the 6th divided by 2. And that'll simplify the math that we have to do a little bit. Now remember, plug in a 4, so it's going to be negative 4 to the 6th divided by 2 minus 4 times 4 to the 5th divided by 5 plus 7 times 4. It's going to be that whole thing minus, and then negative 2 to the 6th over 2 minus 4 times 2 to the 5th over 5 plus 7 times 2. Alright? Now, so now this you would just simply punch into your calculator. Alright? And this first one here, I'm going to have to erase this. But this, I'll erase this right here. This first set of parentheses, when you evaluate at 4, is going to give you negative 2,839.2. And you're going to subtract from that what this gives you when you evaluate it at 2, which is negative 43.6. Of course, minus a minus, so it's going to be negative 2839.2 plus 43.6, and that is going to equal negative 2,795.6. And that is your final answer for number 2. Alright, that is your final answer for number 2. Now, number 3. Number 3, all we're doing is taking the antiderivative of 2 times the sine of x dx. Now, if you remember the little kind of cheat thing I gave you to take the derivative of sine and cosine, remember sine, the derivative was cosine, and then it wrapped back around, and on its way back around you had to multiply it by negative 1. Alright, so now we're running this in reverse, basically. We're starting at sine, and we'll go back to cosine, but on the way by we have to multiply it by negative 1. So, to rewrite this, this 2 can be pulled out. So 2 integral sine of x dx is going to equal 2, and then your antiderivative of sine is negative cosine x. So just simply run all this together, negative 2 cosine x. That is your antiderivative, is negative 2 cosine x. And of course, don't forget plus c, because we don't know what that constant is. Alright, we do not know what that constant is. So we have to keep up with it. We can't just lose it, we have to keep up with it. Alright, number 4. It gives us 2 functions and it says, no, I'm sorry, that's number 5. Number 4, find the area in the first quadrant under the curve f of x equals x squared minus 8x plus 20, and we're evaluating from x equals 2 to x equals 6. All right, now when it says first quadrant, all that means is whatever this graph looked like, it's going to be some kind of parabola. But whatever this graph looks like, we're only worried about what's in this first quadrant here. All right. More specifically, we're only worried about what's between 2 and 6. All right. Because remember, when you take the integral and evaluate it from, say, in this case, 2 to 6, all right, we're evaluating what is underneath that curve. Well, actually, between that curve, so say it looked like this right here. We're evaluating for below this curve, but only as far down as the x-axis. So we're not worried about all of this down here at all. We're only evaluating this. So don't get confused with the wording when it says in the first quadrant. Okay? So we're just going to do the antiderivative from 2 to 6 of the x squared minus 8x plus 20 dx. All right? So when you take the derivative, you're going to get x cubed over 3 minus 4x squared, because this term simplifies, plus 20x, and we're going to evaluate that from 2 to 6. All right, this term would actually be negative 8x squared over 2, but of course the 8 and the 2 cancel out to the 4. That's why I went ahead and simplified it down to the 4x squared. All right. So now again, you just simply plug the 6 in, evaluate, plug the 2 in, evaluate, just like we did number 2, and your answer should come out to, when you evaluate at 6, you're going to get 48, minus, when you evaluate at 2, you're going to get 26.667, repeating. Those two subtracted will give you 21.33 repeating. All right. So that one's not too bad. Just a simple integration. You just take the integral from 2 to 6, so just take your antiderivative, evaluate it at 6, and then subtract that from whatever you get for the value at 2. And f of 6 is 48, f of 2 is 26 and 2/3. So when you subtract 2, you get 21 and 1/3. All right, moving on to number 5. Now number 5, we're supposed to find the area between two curves. All right, we have f of x equals x squared minus 6x plus 11, and we have g of x is negative x squared plus 4x plus 1. Now, the first thing we got to do is we have to figure out where to integrate to and from, or from and to. All right, so we have to get a and b in order to integrate a and b, and then integrate whatever dx. Well, we have two functions. We have f of x, which is x squared minus 6x plus 11, and we have g of x, which is negative x squared plus 4x plus 1. All right, so how do we figure out where these things intersect? Well, it's actually not that difficult. If you set them equal to each other, this is the mathematic way. So if you don't have a calculator and you can't just graph it on the calculator and use the calculator to tell you where it intersects, just set the two functions equal to each other and solve for x. All right? So we're going to make this equal 0. So I'm going to add x squared, subtract the 4x minus 4x, and subtract the 1 minus 1. Well, x squared plus x squared, 2x squared. Negative 6x minus 4x, negative 10x, minus 10 equals 0. All right? So now, you just simply solve this out. I'll save you the time. This doesn't factor. All right? Normally, you'd want to try to factor it first, but this does not factor. So what you're going to have to do is you're going to have to run it through the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. All right? I'm assuming since you're in AP Calculus, you know how to do that. All right? So when you run it through here, you get x comes out to 1.38 and 3.62. All right, because of course you do negative b plus this and you get one of the answers, negative b minus this, you get the other answer. So now, this is where we're evaluating from, and this is where we're evaluating to. So this is our A, and this is our B. All right? Now, let me erase some of this. So now we're doing the integral from 1.38 to 3.62. Now, we got to figure out which function's on top between those two numbers. Well, if you know something about your functions, the negative x squared we know is concave down, whereas the positive we know it's concave up. So the one that would have to logically be on top in this case is the one that's concave down. All right, the one that's concave down, because if it wasn't, they either wouldn't touch, okay, they wouldn't touch at all if it wasn't on top. So it's going to have to be where it's on top. Okay, so this one would be the one that starts out negative x squared. So what we're going to do is we have to take g of x and subtract it from f of x. Okay, we have to take g of x and subtract it from f of x. So we're going to have negative x squared, and this is g of x, plus 4x plus 1 minus f of x, which is x squared minus 6x plus 11, and then of course dx. Now to make this a little simpler, you can go ahead and do this subtraction here. All right, just don't forget that you have to distribute this negative sign through to all three of these. So we're going to have the integral of 1.38 to 3.62 of x squared minus x squared is negative 2x squared. 4 minus negative 6 is 4 plus 6, so that's plus 10x. And then 1 minus 11 is plus 10 dx. All right, so this is the function. I'm sorry, that's negative 10 because it's 1 minus 11, which is negative 10. Sorry about that. All right, so now all we have to do is take the antiderivative of this function and evaluate it, and we're done. So this would go to negative 2x cubed over 3 plus 10x squared over 2, or just 5x squared, minus 10x. We're going to evaluate from 1.38 to 3.62. All right, remember again, you just plug in 3.62, evaluate, and then subtract that from what you get when you plug in the 1.38. And when you do, your answer that you'll come out with is 3.727. All right? So it's just, you could call this A and this B. It's just f of A minus f of B. And that, of course, comes out to the 3.727. All right? So that's number 5. Now let's look at number 6. I'm just going to erase this. All right, number 6. Number 6 says, evaluate 3 times square root of x dx. All right, again, that constant can be pulled out. So it's 3 times the integral of x to the 1/2. Because I always recommend, in fact you really have to, I always recommend taking the square roots or any kind of radicals, converting them into fractions. So now we're going to have 3 times the antiderivative of this, which is going to be x to the 3/2, because we got to add 1, divided by 3/2. All right, well, when you take the reciprocal of that, it's going to turn into 2/3. All right, and now, of course, these 3's will cancel out, and your final answer is 2x to the 3/2. All right, and that's your final answer. Of course, plus c. I know on the answer sheet, if you turn this over, this says 6x, what's 6/3 x to the 3/2 plus c. But what does this equal? 2. All right? So it's the same answer. They just left it in the fraction form instead of canceling out the 3's. All right? Let's move on to number 7 now, shall we? Number 7. If f prime of x equals negative 10x to the 9th minus 14x to the 6th plus 9, and f of 1 equals negative 2, we want to find f of x. Well, first thing we're going to have to do is integrate. So, negative 10x to the 9th minus 14x to the 6th plus 9. Take the antiderivative, which I know you know how to do. So f of x should come out to negative x to the 10th minus 2x to the 7th plus 9x. I'm going to leave the plus c off for a second because we're going to be solving for the c. All right? We know when x is 1, this whole function equals negative 2. So negative 2 equals negative 1 to the 10th minus 2 times 1 to the 7th plus 9 times 1 plus c. All right, so negative 2 equals negative 1, because remember, the 1 is only raised to the 10th, not the negative. It's this. You can look at this as negative 1 times 1 to the 10th. And this is going to be 1 to the 7th, which is 1, so minus 2 plus 9 plus c. So negative 2 equals, this is negative 3 plus 9 plus c. Negative 2 equals 6 plus c. Oops, that's a c. Minus 6 minus 6. C equals negative 8. So we come back up to here, just bring this negative 8 up to here. And this is our f of x. All right, so once you integrate it, and we got the negative x to the 10th minus 2x to the 7th plus 9x plus c, we know that when x is 1, y equals negative 2. So negative 2 equals, put a 1 in for all the x's, solve for c. C came out to negative 8. Throw the negative 8 on the end of your function. All right, so number 7 is right there. Not too bad, not too bad. Now, number 8, 9, and 10. You have to use that table that's on there in order to solve these. Number 8 says use left Riemann sums. All right? So we're using left Riemann sums. Okay? So, the easiest way to do this, really, and it takes a tad longer, but it's the easiest way to do it, is you can just simply make a graph. 1, 2, 3, 4, 5, 6, so it's negative 6. 1, 2, 3, 4, 5, 6, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. All right, I did that because we had to go all the way up to 19. And then we got to go as far up as 15. So I'm going to do these by 2's. 2, 4, 6, 10, 12, 14, 16. Okay. Accuracy is not really that important here. All right. This probably makes it the easiest way to explain it. Okay. So we know at negative 6, we have 12. All right, I'm just plotting the points. Negative 1, it goes up to 14. 5, it goes up to 9. So 5 up to 9. And then at 14, it goes up to 15. And then at 19, it goes to 13. All right, so now we know since it's left Riemann sums, the left side of our triangle, our rectangles, are going to actually touch this point. All right, because you can look at it as our curve looks like this. If you were to connect all these, that would be our curve. So the left corner of our rectangle is going to touch each one of these dots. So let's go ahead and draw them in. So here, it's drawing the straight lines. I know they're not that straight, but just bear with me. And then this comes down to 19. Now, since it's the left Riemann sum, the left side touches. So there we go. Now, we know that the width of this rectangle here is from negative 6 to negative 1, so we know it's 5. And the height of this triangle we know because at negative 6 it's 12, so we know the height is 12. Here we know the width is 6, and the height over here is 14. 14. And then here from 5 to 14, that's 9. And we know this goes up to 9 at 5. So we know the height of this is 9. And then from 14 to 19, we know it's 5. And the height of that is 15. So our total area is going to be 12 times 5 plus 14 times 6 plus 9 times 9 plus 15 times 5. Because all I did was figure up the area of these 4 rectangles, multiply them, add them, and we're finished. All right, after you add all this up, which is a simple punching it in the calculator, after you add all this up, you should get 300, not 330, you should get 300 units squared. All right, so the left Riemann sums, you get 300 units squared. All right. Now, I'm going to transition into 9, and I'm going to try not to erase too much of my picture here. All right, so I don't have to take the time to set it up again. Now let's do right Riemann sums and see what we get. Remember, with a right Riemann sum, the right side of the rectangle touches. So, instead of this being 12 now, we're actually going to erase this line, and our right side is going to touch. So our first triangle is going to turn into that. Now remember, from here to here, at negative 1, what's the y value? Well, it's 14. So now the height of this first one, or the area, is 14 times 5. So it's changed a little bit. Now with this one, we're going to erase this as well, and we're going to come across here. What's the height of that? Well, we already have it over here. It's 9. All right. Our next one, we're going to erase this and bring this across. We know the height here, we already have it, is 15. All right. And then we're going to take this off and connect this one. We know the height here is 13 because at 19 it goes up to 13. So now we have our new areas. This one's 5 times 14 plus 6 times 9 plus 9 times 15 plus 5 times 13. All right, and again, just punch this in your calculator, and it should come out to 324. Okay, of course, units squared. All right. Like I said, I feel this is the easiest way because sometimes looking at the table can be confusing. Just make a quick little graph. It doesn't take that long to draw this out. So just make a quick little graph, and you're good to go. All right. Now let's do number 10. I'm going to use the same picture again, which is trapezoid sums. Okay? Alright, so it's trapezoids. So, again, I'm going to erase all these lines. Be careful, I'm going to be being, if I can talk, I'm being careful not to erase my points, because now you're basically going to connect the dots with straight lines. Okay? So there we go. And of course, we know the heights of all these. The only one we need to write down the height for is this one, which is 12. All right? And we know the formula for area of a trapezoid is 1/2 the sum of the two bases. Well, use the widths here as the height. So the area is going to be 1/2 the height, 5, times the sum of the bases, which for this first one is 12 plus 14. All right, now move on to the second one. 1/2 times the height, which is 6, times the sum of the bases, which is 14 plus 9, plus 1/2. Move on to this one. Height's 9. Sum of the bases is 9 plus 15, plus 1/2. Height is 5, plus the sum of the bases, which is 15 plus 13. All right? Because remember, for area of a trapezoid, it's 1/2 the height times base 1 plus base 2. All right? And again, we're using the width as h, and then this is B1, this is B2. All right? Again, now this is a simple calculator problem. Just punch all this into your calculator, and you should get your area coming out to 312 units squared. All right, now, there's no actual way to find the actual area under the curve that they used, that they got the values of this chart from. All right, because we don't know the actual function. We could try to come up with one, but that would take some time. So there's no actual way, so that's why we have to use the Riemann sums to estimate. We can use left, right, and the trapezoids. And as you can see in this case, the trapezoid is actually the average of the left and the right. All right, because our left was 300, our right was 324. Add them together, divided by 2, boom, 312. All right, so this has been your test review for the integrals in test. So make sure you understand how to do this. You can watch this video as many times as you need, but make sure you're ready to do this when you come to class tomorrow. See you tomorrow.